A user navigates to a standard informational web page on the Museum of London's domain. They are here to read specific, static, historical content, an article detailing the 1878 sinking of the Princess Alice passenger steamer. Before the article loads, a routine interruption blocks the text, the CookieBot Consent Management Platform banner. The user intends to read static paragraphs of 19th century maritime history. In the background, the prompt on their screen represents a live connection to a highly active digital tracking infrastructure. Clicking Accept All functions as a mechanical trigger. That single interaction immediately activates a vast decentralized surveillance network. We are going to bypass the user interface. By expanding the Show Details section of this specific banner, we can reverse engineer the literal text payload hidden inside it. The fine print reveals the scale of the operation. This single museum page requests permission to route the user's data to exactly 1,022 third-party advertising partners. The technical reality of this banner is grounded in web architecture, where it serves as a coordination point for a data network. It functions as a real-time network router and a legal authorization protocol, managing the flow of data to programmatic ad tech vendors. To understand how it works, we will map the persistent storage vectors, analyze the compiled consent string payload, and unpack the vendor topology. True privacy engineering requires treating everyday user interface elements as forensic artifacts of programmatic profiling. The first technical layer of the artifact defines the specific types of data storage mechanisms deployed onto the client's device. The text establishes a baseline standard. Providers like Google DoubleClick rely on traditional HTTP cookies to log user actions. Modern ad tech architecture requires advanced persistence methods to survive standard user privacy hygiene. This schematic compares the 4 kilobyte limit of an HTTP cookie against the larger SQLite architecture of HTML local storage. The artifact shows vendors like TikTok and StackAdapt deploying this exact vector. The diagram expands to include IndexedDB. This structure allows Vimeo and YouTube to drop complex data arrays, specifically designated as logs database v2, directly into the browser's local directories. These advanced vectors bypass traditional session clearing scripts and hold significantly larger profiling payloads. The text explicitly defines long-term data retention timelines for these files, specifically isolating the vendor Archie Inc. Archie Inc. requires authorization to maintain personalized advertising profiles on the local machine for 3,650 days. The colloquial term cookie banner masks a system designed to install decade-long database architectures onto a local machine. The analysis shifts from files stored on the device to data extracted from the device. Under the Special Features 2 section, the document requests permission to actively scan device characteristics for identification. This describes active device fingerprinting. Rather than checking for a stored tracker, the system distinguishes a user by compiling automatically transmitted system data. The text details the specific telemetry points requested to build this fingerprint, installed plugins, fonts, the operating system version, and the screen resolution. Vendors inside this document, such as Tapix, 33across, and AMOB, explicitly mandate this active scanning capability. Fingerprinting allows the ad tech network to definitively link a user's activity across disparate domains. It neutralizes attempts to clear local storage or delete cookies. This introduces a central engineering problem. The museum's web server must legally authorize 1,022 specific external domains in the few milliseconds it takes to render the page. The latency issue is solved by an underlying compliance protocol known as the IAB Transparency and Consent Framework, or TCF. The granular toggles adjusted by the user are not transmitted as individual network requests. They are compiled into a highly compressed digital signal. The artifact's About Ad Settings section identifies the specific local storage key responsible for this signal, the CookieBot TCF consent string. This Boolean array of user preferences is base64 encoded into a standardized, machine-readable string. This diagram shows the broadcast phase. The encoded string is attached to the HTTP header and fired into the programmatic advertising ecosystem. The string acts as a rapid authorization token, instantly allowing cleared vendors to execute real-time bidding auctions. The TCF consent string provides the machine-readable authorization that incorporates this specific user's impression into the automated commodities exchange. Moving past how the data travels, the 14 defined purposes within the artifact reveal exactly why it is collected. The text outlines an escalation of surveillance, starting at the bottom with basic telemetry and performance measurement. This taxonomy chart shows the extreme end of the collection process. Purpose 4 and the Features section authorize the network to combine offline data, like in-store loyalty cards, with browsing history to synthesize composite identities. A critical legal bypass hides within the vendor list, the concept of legitimate interest. While some vendors require an explicit user opt-in, entities like Axiom and Adnami Apes operate under this alternative legal basis. Under legitimate interest, data processing activates by default upon page load, rather than waiting for an explicit click. Stopping this specific data flow requires the user to manually expand the banner, navigate submenus, and actively toggle objections for hundreds of individual vendors. The interface structurally converts user friction and inaction into default legal authorization for deep profiling. The massive artifact we just deconstructed is the standard operating procedure of an educational web page. This is the scale of a single impression. Clicking Accept All triggers the establishment of decade-long SQL-Lite databases and executes system-level hardware fingerprinting. The browser compiles the TCF base64 string and broadcasts your legal status to an automated global clearinghouse. The ultimate purpose of this high-frequency infrastructure is the continuous trading of human attention and behavioral prediction as a liquid asset. True privacy engineering requires seeing past the deceptive simplicity of a user interface to understand the sprawling, predatory network topology it conceals.